we try. This is supposed to be an excuse to drink beer once a month, long time ago. Not anymore.
Oh.
Because people have families and and we try to.
Today we have example.
Yes, maybe. Maybe because Madrid Central also.
Don't scare the people.
It's not so easy to have a bar near a packet. It's very far from my house. This place. So
far from home.
Far from home. So no, a moment. We have a Google page. We have a Twitter account. We have a meetup. We have a Telegram group also. No idea how everybody can join. In Telegram? The link. Do we have a link?
I can share.
I think it's better to put a link on Twitter account.
I think the shortcut is in the
web. Must we have also add to the Twitter account? Maybe not. We don't earn any money for this, so. ¿Presentas tú?
Introduce Laura Morillo. Our staff for today. Working in CITAC, previously in Cabify, Piqué.
Long time ago, we met long time ago in a Ruby on Rails meetup.
Yeah.
More than 10 years. She was very young. Also now.
Very rich in a lot of groups.
She used to be young.
It's an agile girl. Second lady member.
Yeah.
Groups Google member. She's very busy.
Yes.
I think it's the moment. Yes, you can.
Okay. So today we are going to talk or to see a bit of a piece of the infrastructure that we needed to build at CITA to handle some events. So let me introduce myself and I'll save you the job. Well, it's okay. I'm Laura Morillo. You can find my Twitter handles there, and I try to answer usually. Every now and then I forget to check Twitter, and then I can spend maybe a week without checking it, and then suddenly remind, oops, I think that I had something on Twitter. And the alerts are not always arriving, but it's usually a good way to contact me. So if you have any question after the event, I usually see the mentions and I can answer. As they have said, I'm also involved in several communities. I'm a GDG, that is Google Developers Group organizer. There I have the role of a Women Checkmaker ambassador, that they rename it now. And it's a role focused on trying to improve the diversity that we can see we usually lack in the tech events. I work at CITAC as a tech lead, but I mostly work on the backend side of an application called SSP, and I will tell a bit more about that later. I've been working for 12 years with a lot of different technologies, like, as he said, Ruby in the past, and Groovy, Java, C, C++, a lot of them. Now I mostly work with Node.js, with Spark, with Scala, a bit of the infrastructure part with Kubernetes, for example. And I love working at startups, because when you have to work in a startup, you need to learn a lot of things, because you need to do a lot of things. When I started working at SIGTAG 3 years ago, we were a team of 6 developers to do everything. And we had some people dedicated to work only on front-end things, and the rest of us, we had to work on the back-end and on the infrastructure. So that's why I wanted to do a note. I'm not a DevOps. I like to learn new things about infrastructure, and I try to learn more things about automation thing and everything related to the DevOps side. But my experience is mostly as a software developer. But I want to share the path that we follow to build this event system and what we learned in the way at SIGTAG. I'm going to do a bit more, yeah, but it's not because I want to charge you talking about SIGTAG, but I want you to know what SIGTAG and the business that we do, so you can understand the problem that we were trying to solve. Because I think that it's the most important part, to understand what we need to solve, and not only the technology that we use to do that. At SIGTAG, we work with online advertising. So we place those annoying ads that you can see in a lot of pages, but we try to create a less annoying advertising media. We work with in-image advertising, so we use mostly to place our ads the images that are inside the articles that you read, for example. And I work in a piece that is called SSP. It's a supply-side platform. With a supply-side platform, what we do is that we receive a request to place an ad whenever a user visits a page. So every time a user goes to a page, whenever you go to pages like Marca, Mundo Deportivo, Confidencial, etc., you are also sending traffic to SIGTAG. Then we take the information from the user, the location, the country, from the IP, or information like that, and we contact to a lot of different third parties to tell them, hey, do you have the possibility to place an ad here? Do you want to place your ad here or not? And then they respond with bids if they want to set their ad there. And we have to decide here which ad is the best one to place in that spot that we are using at the moment. So the thing is that this is completely a black box for business people. They know that we receive requests and they know that we place ads, but they have no idea about what's going on inside. That's what motivated us to build this event system, because they needed to have a lot of information about what was going on. They needed to know if the third parties were receiving or not the request, because we were blocking the request before. If they were bidding or not, if the amount that they were bidding with, and also who was winning or who was losing, because they need to contact the third parties to let them know, hey, you are never bidding, so we don't want to work with you if you are not going to send us any ad, and that kind of things. But they didn't really have any information unless we managed to expose that. That's why we decided that we could work with events, and that way we could log everything that was happening from the beginning, from the moment that a request is received, until the moment that we decide the ad that we have to return to the page, or send a no bid saying that, I'm sorry, but we don't have any ad to display you. And we decided that we had kind of two different types of events. We have some events that we knew that we were going to use them to create some reports later, because it was crucial information that we needed to store and that we needed to process later. So we have information like the amount of requests that are received, the amount of requests that we send to every third party, the amount of responses, how many timeouts, how many bits, how many no bits, the size of the ads that we send, information that we are going to handle later with some reports that business people will be able to use to get more information from what's going on inside. But we also had some information that we didn't want to process, but we knew that sometimes could be useful. So we decided to treat that information like a kind of debug information. Things like the ad, for example, that is being returned. Whenever we receive an ad, we can receive different kinds, but so you have an idea, when we receive a video to place it, it's a quite big XML. So if we are going to work with them, process them, and store them, then we knew that we were going to handle quite some big amount of information. So we decided to start working on which solution could we use to provide this feature that business people was needing. In general, the architecture that we had at that moment for the whole production system, it was based mostly on microservices built with Node.js that were running in a Kubernetes cluster on Google Kubernetes engine. We were also using Spark to communicate some of the services, and also to we were using Kafka to communicate some of the services, and also to send some messages to Spark that we were already aggregating, because we had in another part of the system a similar event service, but that were handling not information so big, and that now we are also migrating to a different infrastructure. To avoid needing to manage and to need to handle everything related to the Spark cluster, we were using Dataproc. And we were also using as our main database MongoDB. So these were the tools that we were already using. And we knew that one part of the application we were going to replicate what we had already done to create our reports, and because we already knew that that worked. So we knew that at some point we wanted to have the whole information that was being generated stored somewhere. We have not decided that yet. And from that, we wanted to import that information in a Spark task that would only aggregate the information and store in our MongoDB the reports already processed and ready to be served to the business people. So this part was clear, and we knew that we wanted to use this infrastructure because it had proved to work fine, for at least for what we needed here. But we still needed to manage some way to handle those events and store them somewhere. And when we started working on this solution, the project, the SSP project, was starting. We were only having some connections on production, not too many, so we were not having too many requests. But at the moment, we are handling around 3,000 requests per second. So we knew that we needed something that would grow a lot. We started checking how things are done. And we started investigating the suggestion by Kubernetes about how to handle logging. Two of the approaches that are proposed, for example, in some of the blogs, are or by creating a sidepod container that will run with your main application and will be the one taking care of the information and sending it to your logging backend, or directly connecting your application with your logging backend. So in general, we had these two approaches. And we started dividing in different options. So, okay, the first option, it would be the sidecar container that they were proposing. We would be using technologies that we were already using, Kubernetes and our pods, and we would be adding only a Google Cloud Storage to simply send the information there. So the process would be kind of simple because we would have our SSP process generating and writing information to a file, for example, and we would have a service running in a sidecar container, getting this file information and taking care of sending it to Google Cloud Storage. It had some advantages, for example, that we would be dividing the SSP and the event logic responsibilities. So the SSP wouldn't need to take care of things like rotating the logs, for example, because that was kind of completely out of that. And if we needed to do that in a different service, we would already have a service specialized on doing that. We would be also using the existing architecture, so we wouldn't need to take care of more pieces. Consider that we are a small team. We don't have anyone fully dedicated to the infrastructure. We don't have anyone for DevOps. So the people taking care of DevOps is mostly some backend people. So we need to consider the amount of work that something will add if we want to use it. And also, with that approach, we wouldn't have any kind of vendor lock-in. In the end, you're using Kubernetes, so if you want to migrate your Kubernetes cluster, your pods will go with that Kubernetes cluster, and switching from using cloud storage to using, for example, Amazon isn't really a big change. And it would be quite easy. In the end, it's simply a storage system where you'll leave the log information. So even if that's not really something really strong to decide, it was another advantage. In our case, in the end, at the moment, we are running everything on Google Cloud Storage, Google Cloud. So it wasn't really something that could make a big difference, but it was something to consider. But it also had some disadvantages. First, that we would need to handle and take care of the life cycle of the pod, because for us, it's really important not to lose those events. So we need to ensure that if anything happens and Kubernetes is going to restart one of our pods, we need to ensure that the whole information has been saved and has been sent to our storage. And that is doable, but well, added some complexity, because at the moment we don't need to worry in any of our services because of the restart. All of them can recover automatically. We would also need to add some kind of persistent layer to share this document. Again, something not really difficult, but adding again more pieces to the system. And the events wouldn't be persisted immediately, because we would be leaving the information inside the pod, and at some point the event service would act, would check the information, and would send it to the Google Storage. But as we said, if we had some kind of not properly handled situation, you could be losing all the information that hadn't been moved on time. The option 2 that we decided to evaluate was a direct connection with BigQuery streaming. Do you know BigQuery? Well, BigQuery in the end allows us to store and process big amounts of information. So it's a big database, but properly prepared to handle big amounts of data. So that was why we decided to consider it, because we knew that we were going to handle a big amount. And one of the features that they provide is an API to do a streaming directly to a table. So you can simply use their API and their library, because they also have libraries for Node. So we would only need to add their library to send directly the messages to BigQuery, and then we will have immediately all the information persisted, and we wouldn't need to worry about duplication, and we wouldn't need to consider how maintaining everything. So it had some advantages. Simplicity, because we only needed to worry about using a library to connect to the API, and the library was quite easy. You only need to take the dataset, take the table, send message. When you are planning to do inserts, then it's quite straightforward. The events, they would be immediately stored. It takes a small amount of time for them to really persist and display everything that you are sending through a streaming, but it's a small amount of time. And since the moment that they receive the message, they store it even if it's not already on your table. So you don't have to worry that if the service dies because of any reason, all the messages that already happened, they had been sent, and they had been properly stored. Also, with BigQuery, we would already have the information ready to be queried, and we could get some extra information, because not all the information that we can get is always the information that we have in the reports. That's why we also keep some debug information, because sometimes there's information that we are not really processing, but can be useful. So BigQuery is a really useful tool at that moment. And we wouldn't really need to do anything to maintain it, because it's a service, so it's Google who's taking care of maintaining the information that you are storing. The first disadvantage that you need to consider is the cost. As a provided service, you have to pay for it. You have to pay for the information that you store, but you have also to pay for the information that you store on Google Cloud Storage, even if Google Cloud Storage is cheaper. Also, you need to pay for sending the information. Yeah, I don't remember exactly the price, but it was something like I think that a bit less than 1 cent for every 200 megabytes or something like that. So depending on the amount that you are sending, it could be really expensive or it could be cheap enough. And also we needed to consider if we could have some connection issues, because from the moment that we send the event, we know that it's going to be stored, but if we had connection issues with BigQuery, then we would be losing a lot of events. And we hadn't used BigQuery before, so we didn't really know how well this could be. The third option that we decided to evaluate, it was based on Kafka and Spark. We already had a system sending some kind of events to Kafka to be later processed by Spark. So we could use a similar approach to send the message from this SSP directly to the Kafka. From our Spark server, we could connect to the Kafka, read the different messages, process them, and write some batches of information to Google Cloud Storage to generate the log files. The advantages that we were already using, we would be already using the existing infrastructure, so we wouldn't really need to worry of maintaining anything else, but we would need to consider how it could affect the existing infrastructure, the amount of information that we were going to send now, because we were going to handle a lot more information that we were handling before through our Spark system and through our Kafka. The cost was quite controlled because we knew that even if we needed to scale a bit that infrastructure, we could need to add some machines to the clusters, but it was easier to control it, and it is not so directly the increase. When you are sending a service like BigQuery, receiving 300 messages and receiving 600 messages can really make a difference on the cost that you have. But when you have your own infrastructure, handling 300 messages or 600 messages, depending on the load, can mean adding a bit more or needing a bit less, but it's not that much the amount that you need to grow to handle that. And with our Kafka, the data would be already immediately, it would be again immediately stored, because Kafka handles the persistence. So every message that we send, it would be already stored there to be read later. So even if the SSP fails or is restarted, then we could still read the information from the Kafka queue. The disadvantages, well, we started having a lot of pieces involved to do only one thing, because we need Kafka, Spark, cloud storage, so a lot of things, a lot of pieces to handle together. And something that also worries us, it was the event size. As I said, we have two kinds of events. The report events, that we call them, they are quite controlled, because we only send the properties and the information that we know that is going to be needed to do some reporting. But with debug events, we are sending a raw event containing everything that is happening, even the whole creative. So even a XML that contains the whole information about a video that needs to be displayed, with a lot of URLs that will track if the user sees starts seeing the video or sees half the video, or everything is tracked, everything, So the XML files could be quite big for Kafka messages. It's probably more than a double of the recommended size. So it's a recommendation, so you can increase it, but you know that the performance of your Kafka can suffer because of that. So we were a bit worried with that. Considering the three options that we had and evaluating everything together, we decided to go with the BigQuery streaming approach. Why? Because it was the fastest for us to implement and test. We didn't need to spend any time working on the infrastructure, because everything was going handled by Google. We only needed to handle the connection with BigQuery, so that was quite straightforward. And the team, we are only 2 people, so we didn't have a lot of people to work on different paths. And as I said, we don't really have someone working on the infrastructure, and the project was just starting, so we needed something to prove that it could work and that it was a useful tool and that it could later grow. As I said, Well, the whole infrastructure was the SSP sending directly using the API messages to BigQuery, and after that we had a Spark task, a Spark kind of service that would import hourly and daily the information from certain BigQuery tables, would aggregate the information and would generate the report and store everything on the Mongo. Having everything together inside Google was a big advantage here, because we didn't suffer almost any connection issue with BigQuery. That was one of the worries that we had when we were planning everything. And also the connection between the DataPro cluster and BigQuery, it's quite easy. It has a library that automatically sends the request to export the information, and the library automatically sends the information from BigQuery to a cloud storage, and then imports the files to be processed with Spark. So we were quite happy with this solution, because we also had the information to use it immediately if we wanted to do some custom queries with BigQuery. So, cool, solved. We already had our infrastructure working, and we had the business needs solved. But no. We were really happy with our system, and we could use it for 4 months, more or less. No, maybe more, probably 6 months, something like that. And then we started facing this. Google has some limits. Depending on the product that you are using, you can face some kind of soft limits that you can request for them to be increased, or some hard limits, like this. When we started working, you were limited to 10,000 rows per second per table, and 100,000 rows per project. When we started, that was it wasn't an issue at all. It's like, wow, it's a rich problem. But after a few months, when we started running a lot of things in production with the SSP, because it was working and it was a useful tool that they wanted to use, we easily started going over the 1,000 rows. After that, they increased the limit per table, and now I think that it's only it's also 100,000. But at the moment, we on peak times we are handling around 160,000 events per second. So this wasn't a solution for us anymore. We needed to reconsider again everything. So it was right, and I think that we really chose the right tool at that moment, because we needed something that could fix the necessity that we had at that moment, and we did something fast, and it worked. But we needed to consider now the right tool that could properly scale with our necessities, and with the scaling necessities that we were really having at that moment. So we had to decide. And we decided to go to the Kafka and Spark. Why? Because in the end, it was quite similar to what we already had in another parts of the system, and it was already infrastructure that we knew that could work, and we didn't need to face some other strange problems. We only needed to ensure that the size of the messages wasn't really a problem. The whole process now had a lot more pieces. and we didn't know if it was going to be maybe some kind of problematic mixing everything together. The whole process now was that the SSP was sending messages to Kafka. We had an Apache Spark task or service reading the information from Kafka every 5 or 10 minutes, depending. We have been playing with that. Taking all the messages to generate files and save those files to cloud storage, and a different job runs every hour and daily to take the information from the cloud storage and generating the reports to saving the information to Mongo. After checking the different options that we had with Spark, we decided that we were going to use Spark structure streaming. We had been using Spark streaming before, and it worked fine, but we had some issues when persisting the offset sometimes. And even if in the other system we didn't really worry that much because of that kind of issues, because it wasn't really a problem if some event was duplicated. In this case, as we were going to use the information for things like sending the invoice to the client, we needed to ensure that we were not losing events and that we were not duplicating events either, because we don't want to charge more than we should. So Spark structure streaming, if you don't know, I really recommend you to have a look of it, because it's a system that is fast and scalable, so that meet our needs, because we needed something that could really scale to our needs. It's also fault tolerant and provides the ability to ensure that the documents are processed exactly once. And the good thing is that it's really, really simple to use. What we need to do is, on one side, to define a read stream. In this case, we were reading information from Kafka. We set the brokers of Kafka, the connection to Kafka. We set the topic, and we are using 2 different topics. We are using one topic for the report events that we want to ensure that are going to be always working, and that we don't have any issue with that topic. We really need to ensure that. And another one for debugging, where we know that we can be less strict, and if we have some problem with that, it's not really a big problem for us, because we only need to run some custom or some specific queries or search to get some specific information. So it's not really that critical. We designed the policy of the connection with the Kafka about when it's connecting for the first time, where it should start, if it should start with the first message that it was sent and is still stored, or with the latest. And we defined the maximum amount of messages that should try to get from Kafka for every time that it runs. You can see the number is not bad. I think that we left it in 150 million messages, and this is now running every 10 minutes. After that, here we are reading the information, so getting the information from Kafka, and now we need to store it. The code can look difficult, but most of the code, all this part, is only to transform the information that we are receiving. to really store the information, we only need this part. What we are doing here is that the messages that we are sending contains a timestamp. We want to ensure that every message is stored inside a folder with the structure year, month, and hour. This structure helps us to be able to process, for example, only 1 hour, or reprocess it later if we have some issue with it. And also, if we want to get some information real time, we can import the logs from the last hour only to see what is happening instead of needing to import, for example, the whole day. Now here, what we are doing is transforming this timestamp into date and get it in the end, the year, month, day, and hour. We define the columns that we are storing, a timestamp, a request ID that allows us to identify all the messages that have been created or that happened because of the same request. The event type is the event, the name of the event, and the log. It's a JSON with the whole information that we want to be stored for this log. Here we are taking all this SQL information in the end, and we are telling that we want only 10 groups of data. So we are grouping, we are ensuring that every time the application runs, it only generates at the end 10 files. This wasn't always here, and what happened was that it was creating a lot of small files. For cloud storage, it's not really an issue that, but after that, we had a task that was importing the whole hour to process the whole hour together. And for that task, having a lot of files is worse than having a smaller number of files, but bigger. Because the task needs to perform before getting the information and before downloading the files, it needs to check the files, list all of them. So it's not the same if you need to list 60 files or 600 files that if you have to list 10,000 of files for every request. Also, you need to get meta information from those files, and after that, downloading all of them. So the amount of requests that you are having increases a lot. So when we change to decide and handle the amount of files that we were generating with every iteration, we improved a lot the performance of the other task. So we create a write stream with this structure and these columns. We are using Paquet, and we will talk a bit more about that and why. And we tell it to use an append mode. So it's the write stream is taking care to ensuring that information is kind of appended and it's not replaced. So we are not duplicating any information. We set the path that we are going to use to store. And for this, we are using 2 buckets, different for debug and for the report information. And we will see later why using 2 buckets instead of 1. We need to define also a path for it to store the checkpoint, so it can trace where finished the task the previous time to continue later. And we define the frequency that we want for this trigger. In this case, we are now running it every 10 minutes. When we are using a write string to files, and as we are defining also the checkpoint location, we need to take care, because if you want at some point to move the information to a different folder, you will need to take care, because half of the information about the process and the checkpoint information is stored with the information, and part of the information is stored at the checkpoint location. So if at some point you want or you need to move it to a different location, you will need to ensure that you are moving also the checkpoint location, or you will suffer some issues. I know it. BigQuery, again, now we are not really using it for the process, but the good thing is that inside Google you have a good connection, and it's really easy to import a directory from Google Cloud Storage to BigQuery. So for us, it continues being quite easy if we need to run some custom queries and to process in a custom way some information every now and then. It's pretty easy for us to directly say, okay, I want to create a table using Google Cloud Storage. You can define the path to a file, or you can also use wildcards. So that allows us to decide if we want to import 1 hour, 1 day, or even 1 month if we would like to do that. But that's quite a lot of information to do it. So we have not really at the moment done that. Because after that, BigQuery also has pricing for the query. So you have to pay for the amount of information that you are processing in every query. So running a query with 1 hour, considering that the price it was $5 per terabyte that you process. So 1 day for us is at the moment more than 3 terabytes. It would be $15 every time that we want to run a query only for 1 day. So if you want to run a query for 1 month, you can do the math. That's why it's quite useful for us to have also the division in hours, because quite often we only need to process the information in 1 hour to be able to handle some information, like, okay, if one campaign is running properly or not, things like that. We can get it directly from the log information that we have here. Some kind of hints if you want to use Google Cloud Storage. Parquet. It's a compression for the files. It's a format that will compress the information. So in our case, here we have, for example, the size of the information for 1 day as it is stored using Parquet format, and it's around 1 terabyte. And the same information, after being stored in BigQuery without the compression, is 2.5 terabytes. So it's more than double. As you are going to need to pay for the space that you are going to use, it's a good recommendation to consider using Parquet as the format for your files. But it has, for example, one disadvantage. When you are working with Google Cloud Storage, BigQuery has a feature that allows you to create a table that will not contain directly the information, but that will take the information from an external source. So you can say to BigQuery, hey, I want to create an external source that will point directly to files that I have in Google Cloud Storage. So instead of needing to do the process that we are doing here of importing the information and creating a table, that even if it's fast, For 1 hour, it takes maybe 2-3 minutes for us, so you need to wait that time. You could directly connect to that source, but that doesn't work if you are using Parquet at the moment. You can use Avro, you can use JSON directly, but if you are using Parquet, you cannot use this direct connection. It's one trade-off that you need to consider if it's a feature that you need to have, or if it's okay to work with this process like us. Another good feature that you can use is lifecycle rules inside Google Cloud Storage. I said that we were using 2 different buckets, it's like 2 different folders inside Google Cloud Storage for our information, one for debug and another for the report information, and it's mostly because of that. With the lifecycle rules, you can define policies that you want to apply to your data. So you can define things like, okay, for information that is older than 31 days, send the information to call line. Call line is a different kind of Google Cloud Storage that is prepared for information that is going to be rarely accessed. So you pay less to have the information there, but it costs you more if you want to access and to get information from that data. In our case, we know that for the reporting data, after the month has finished, we rarely need to access that information. So if we send that information to call line, we will still keep the information, so we will have it if we need it, but we are going to save quite some money. And after 6 months, for example, we are not going to need the gross information anymore. We already have the reports that we generated from it stored in Mongo, and we don't need the gross logs anymore. So we can define a policy to remove it. In the case of the debug system, as we rarely use them to process information, we know that we don't really need to store them for 6 months, because the information that we can get from the debugging events, it's information that is more recent. I want to know that this campaign is running properly. I want to see the whole creative that is being returned, or the ad that is being returned, because I want to test it to see if there's a problem with this browser, for example, that kind of thing. So we don't really want to check information from 3 months ago. And having 2 different buckets, we can define different policies for the different kind of information and control even more the cost of this solution. So now, yes, we consider that we have a solution that works, is solving the needs that we had. It is proving that it can scale with the amount of information, because the system has grown a lot, and now it's allowing us to store and process more than 3 terabytes per day. So, any question? Okay, I'll try. Okay. Yeah. The replication factor that we have for these topics is 2. Uh, yeah. I don't know if in Kafka we have changed the configuration for that. So I would need to check what's the default, because I don't. Do you know what's the default events? Okay. Yeah. Yeah. Hmm. Yeah. Hmm. Yeah. The good thing is that we seldom had any issue with the Kafka server. It's quite stable. It was one of the worries that we had, and then we started gradually adding information to it. We didn't switch everything from 0 to 100%, but we started processing only some of the reporting events. And at the beginning, we had some problems because of the leader memory, but we tuned it a bit, and everything worked pretty smooth from that point. So that's the good thing. I would need to ensure if we are forcing the AZK before ensuring that it's to both replicas, or it's only leader. I would need to check that. Yeah. Wow. Kafka Connect instead of Spark. No, I have not tried Kafka Connect, so I don't know exactly the advantages that it could provide. Mhm. Okay. Now, in our case, going with Spark was also kind of linked to going with something that was in between, like why we decided to go with Kubernetes, something that was in between. We already had the cluster prepared with Dataproc, so we didn't need to worry about that. They were going to provide it, and we only needed to worry of the applications that we run inside. Oh, you mean the what? The repartition, coalesce here. Mhm. Yeah. Mhm. Now, in this case, what it's doing is that it has more partitions before this point, depending, for example, on the Kafka partitions that you are using. So you can improve the parallelism of the ingest of the files. But at this point, the whole information that has been generated is going to be split in 10 parts. We are not going to have 10 files per day, but we are going to have 10 files per execution. In our case, it's 10 every 10 minutes. Or if we change the execution to 5 minutes, then we will have. So what it's doing is taking all the messages generated and dividing them in only 10 parts. No, it's 10 per execution, and in our case, we play with that because we know that even if we grow, we are not going to duplicate, well, who knows? But we are not going to really duplicate from one day to another. So we can have an eye and decide at some point we know now more or less, as we know the total size of the folder, we know the size that is being generated more or less every hour, and we know that now it's usually around 500 megabytes, I think. So we can play, and at some point maybe we will increase this. In the end, it's also a trade-off, the performance of the other task, but also having something manageable here. Question? Okay. It's not having no, it's not that we had 2 checkpoints. It's that the right stream, they generate some part of the checkpoint information here at the checkpoint location, but it's not checkpoint, but it's kind of the progress of the generated information. It's also stored beside the information again here the path itself. So I think that this is, for example, no, because you are not going to see the information that is inside. You are only going to see no. You're only going to see the structure that I already told, so that's not an issue. And the files. But it's also storing some metadata information here, and well, yeah, inside the different folders there are also information about the generated parts. So if you switch to a new one, that information is not going to match. It's kind of something like that. And that's why one of the things that you need to take into account is that if you want to ever change one, you will need to change both, or they are not going to match, and then it is going to get completely crazy. Well, the Spark cluster is completely outside. It's a data pro cluster. It's one service that Google provides. So they control the cluster and they handle it, and you don't need to worry about the maintenance of the cluster. It's not providing really a lot of things in the case of a Spark cluster, but it helps us not to worry too much about some things. And also Kafka. Yeah. No, we have Kafka outside of Kubernetes. We had used some Kubernetes feature that is the stateful set, that is supposed to be for these kind of things, but we use it for Redis, and even with that we had some issues with the restarts, that kind of things. So we don't really want to have that kind of strategy, and as we don't really need the scaling, for example, abilities that Kubernetes provide us for the Kafka cluster, because we are not going to scale it automatically. And we can handle taking care of restarting if we have any kind of issue with one node. That, as I said, that seldom happens. So we didn't really see any need on trying to migrate everything inside the cluster of Kubernetes. But sure.
What is the maximum size of the event you are able to have? And did you have any trouble with the method size at the end, or it was okay with 30 events?
In the end, we didn't have any. We needed to ensure, because in the past, for some of the microservices that are communicating through messages, depending on the library, you can also define the limits of the size. So it happened to us there that sometimes you could only notice that suddenly one of the partition was stuck and the messages were not processed. But at the beginning we didn't really know why, and after that we discovered that it was because of that, because the message was too big and the library that we were using to read had this limit lower than the size of the message being generated, so the message could not really be processed or being fetched. So it was completely stuck there, and you needed to discard it. It was kind of a mess. That's why we had some worries that could happen. But we made some tests, and we have seen that with the connector that we have with Spark, that's not an issue. It's working fine. The max size at the moment, well, I don't remember. I can check it later, because we have a lot of charts displaying everything, the amount of events that we are processing, and the amount of bytes that are being processed for every topic at any moment. So I can check it later and tell you the average of the size that we are having at the moment. I can ensure that the size of the debug paths, they are more than double. It's almost, I think that's 3 times the size of the messages that we were previously processing. You can, yeah. Okay, you can ask. At the moment, we have not really needed that. You shouldn't have any problem except of paying more, because you are accessing information that shouldn't be, but the importing time shouldn't really be affected, I think, because they still have, it's still connected through the same network. Something that you need to check also is the zone that you are using to store the information and for your BigQuery table, because you need to ensure that you are working on the same zone, or you would have also charges because of sending data from one zone to another. Things to consider. But I think that the time shouldn't really be an issue. We didn't really need it yet, and we don't really expect to need it that much. It's more like a kind of safe to leave it for at least 5 months there in case something happens. But at the moment, with the processed information, they are having enough after that time. Any other question? Well, thank you. And we are hiring someone to work on the. It's to work on the client. I'm sorry, but if you know someone that could be interested in working with it, because we look someone who knows about JavaScript, but and it's going to be working